Alright, what you're looking at here is the Cartesian coordinate system. And basically what you see here is two axes. You got the x-axis horizontally and the y-axis vertically. Anything to the right is considered an x plus direction. Anything going to the left is an x minus direction. Anything away from you on a machine is y plus direction, and anything coming towards you is the y minus direction. So these are the way the axes are laid out on a machine. So if your tool moves to the right, it's traveling in a x plus direction. If the tool is moving away from you, then it's moving in a y plus direction. If it's moving towards you, y minus. And if it's moving to the left, it's an x minus. So basically the Cartesian coordinate system is divided into 4 quadrants. And the way they're numbered is the upper right is quadrant 1, the one to the left is 2, then 3 and 4. Now there are infinite amount of points inside all of these quadrants, and depending on the location of the points in each quadrant, it will either have a plus or a minus value in the x and y. So any point that's located in the first quadrant in x and y will be a plus in x and a plus in y. Remember, we're going to the right, so x is plus, and we're going away from us. Now I'm saying away from us because that is the axis, the way it is on the machine. The y-axis moves away from you, or is perpendicular to the x-axis. Okay, so any points in this second quadrant, the x value will be a minus and the y value will be a plus. In 3, the x will be a minus, the y will be a minus. And in 4, any points in that quadrant will have an x plus value and a y minus value. So that is what we're going to learn in this session, is finding points in each quadrant and putting the x and y values to it, and then also determine whether it's a plus or a minus. Alright, so in this first example we have a 8 by 8 square, and the origin is right in the middle of that part. So what we're going to do is find the x and y coordinates of the intersection points at each corner. So the first one we're going to do is the intersection in quadrant number 1. I want to select this corner, and the x value is 4 inches and y 4 inches. And notice they're both plus. Now, one thing I want you to realize is in a program, if that's a coordinate, there's no need to actually add the plus sign. Okay, your control will assume that if there's not a minus, that it will be a plus. However, if you go to quadrant number 2, if it is actually a minus value, then you have to specify the minus. Okay, so that's what the program is going to look for. So that is the coordinate in quadrant number 2. X minus 4 inches, y 4 inches. Quadrant number 3, I'm going to pick this corner. Notice both x and y are minus values. Then quadrant number 4, x is plus and y is minus. So how do you come up with the x4, y4, or x4, y minus 4? How is that determined? So we know that our origin, where the x value is 0 and the y value is 0, is the center of the part. Okay, so this point right here in quadrant number 1 is at a distance away, and I'm using even values here. So each increment that you see here is 1 inch. So we're moving over 4 inches in x, and then y plus 1, 2, 3, 4. So that's how we come up with the x4, y4. So how are these points used in a program? So any of these coordinates represent the center of the tool. I want you to realize that, okay? So if we were to make the tool walk around this part in a clockwise direction, then we would give it the first point, which would be x 4 inches, y 4 inches. Okay? Then the next line in the program, we want the tool to go to the next intersection. So the next line will say x 4 inches, y minus 4 inches. Then the next line would tell it to go to x minus 4, y minus 4. Next line, x minus 4, y 4. And then we want to make sure that we cut that top edge. So we need to come back to x 4 inches, y 4 inches. So that is how these coordinates are used in a program. It's just a point-to-point connection. So if these were the coordinates that were in a program, then this is the way the tool would travel around the part. It would start at this first point, because that's where we're telling to go to, and then when we hit cycle start, it goes to the next point in a y minus direction to get to the next intersection. Then it travels in a x minus direction to that corner, then a y plus direction to get to the next corner, and a x plus direction to get back to the first intersection. So that's exactly what the machine will do with these coordinates. Alright, so let's talk about the x and y coordinates of this shape right here, and then we'll simulate the tool paths of it. So we're going to find the x and y coordinate of this intersection right here, which is located 1 inch in the x minus direction and then y minus 1. So the x and y coordinate for that would be x minus 1 inch and y minus 1 inch. Then the next point, we go from this point to this point. Again, we're going to travel around this part in a clockwise direction. So this point right here is in a 1, 2, 3 on x, minus 3 on x, and minus 1, 2, 3, 4, 5, 6 on y. So that coordinate will be x minus 3, y minus 6. Then the next, we have 1, 2, 3, 4, 5, x minus 5, y minus 1. So those are the coordinates. And notice, because the part is located in the third quadrant, all x and y values are minus. So let's do a toolpath around that. Alright, so the first point is going to be x minus 1, y minus 1. That's where we tell the tool to travel or to wrap it to in the program, and from there start going around this part. So what I want you to notice is that when it goes to the next point, it's going to do that in a straight line. It's not going to do a zigzag. It's always going to take the shortest distance between those 2 points. Okay, so that's basically how the machine interprets these coordinates. It always is going to be the center line of the tool and also the shortest distance between those points, therefore creating the angles like you see right here. Alright, so here a little bit more complex shape. You can see the origin is located somewhat in the middle of the part. I placed it there just to give you coordinates that are going to be plus and minus. Okay, so what we're going to do is we're going to find each point starting in this upper right hand corner and working our way down. And what we want to do is find the coordinate to each intersection, because that's what we need to program, is every intersection that we see in this part. Okay, so we're going to do that in a clockwise direction. We're always going to travel our tool around the part in a clockwise direction if we're milling from the outside. So that is the habit that I want you to start thinking about. Okay, clockwise direction, that means we're climb cutting, and that is what the machine likes, is climb cutting around a part. So notice all the x and y coordinates being plus and minus. Now that one lays right on the y-axis, so that y-axis number is 0. Then add an angle to that point, then to that point, that point, that point, and then we're back to this corner which we already have. So these would be the coordinates that you would have to find when you start writing a program, and it will be in this order that you write the program. Okay, and I'm going to show you what that toolpath looks like. So now I'm going to be sending you some attachments with shapes just like this, and you're gonna do exercises finding these x and y coordinates. Okay, let's take a look at the toolpath. Alright, so if we have placed the coordinates of this shape in the right order, then the toolpath will look something like this. It will go in a clockwise direction, connecting each intersection point. And you can imagine if you get these coordinates backwards or not in the correct order, then it will skip and make the shape of the part incorrect. So this looks correct. Let's take a look at the program and look at the order of the coordinates so that you can see what that looks like. What I want you to notice right now is the x and y values that we found on our part are all listed in the order so that it will travel around the part in a clockwise motion. So I'm going to single block through this program and show you that this is how the program uses these coordinates to create the shape of your part. So right now we're going to a z minus, so that is the depth of the tool as it engages inside the part. And then we are in position right now. You can see we're sitting at x 4 inches, y 5 inches away from this origin. So each line that I execute, it is going to finish that toolpath, and because I got it on single block, it will stop until I hit cycle start again. Your machine is capable of doing that too if you select the single block option. So each line you can see as it completes is connecting intersection point to intersection point, creating the shape of your part. Alright, so that is lesson 1 of G-code programming. So I'm going to send you some attachments of some shapes showing the origin, and what I want you to do is practice finding those x and y values and make sure you get them in the correct order, moving around the part in a clockwise direction and then in order so that the part shape is correct and it doesn't skip around from point to point. So download the attachments, and that will be the exercise for this lesson. Good luck.